Let's perform a partial fraction decomposition to this rational function. So the first thing we want to do is check the degree of the numerator, which is 2, and compare it with the degree of the denominator, which is 3. 2 is less than 3, so this will allow for a partial fraction decomposition. Now, we want to see if we have linear factors or irreducible quadratics. Looks like we have nothing but linear factors. In fact, we have a linear factor of x with multiplicity of 2. And then we have another linear factor called x minus 2 with multiplicity of 1. So what I usually like to do is I like to write the linear factors with multiplicity of 1 first. So with the commutative property of multiplication of real numbers, we could switch the x minus 2 and the x squared. So let's perform a PFD on this scenario. So let's look at 3x squared. So I'm doing this off to the side because I want to be neat. I'm going to do most of the work off to the side here. 3x squared plus 1 over x minus 2 times x squared. So because we only have linear factors, then the constants in the numerator is just going to be a over x minus 2 plus b over the linear factor of x, and then plus a c over the linear factor of x with multiplicity of 2. And now we're ready to solve for our a, b's, and c's. So multiply both sides of this equation with the lowest common denominator, and we get 3x squared plus 1 is now equal to a times x times, let's try that again. A times x squared plus b times x minus 2, and then plus a c times x minus 2. Since we have linear factors, it makes sense to test this triple star equation. So why don't we test? Let's test x equals 2. If x equals 2, we get 13 is now equal to 4 times a plus 0 times b plus 0 times c. So that quickly gets us a. A is going to be 13 over 4. Now, how do we get b and c? Well, we still have another linear factor. So why don't we test what do you think? What should we test? Why don't we test x equals 0? If we test x equals 0, we get 1 is now equal to 0 times a, 0 times b, and we're left with negative 2c. I guess I could write it way over here to help you see it. What does that mean? That means now c is equal to negative 1/2. Well, now we're out of linear factors. So why don't we change this equation to a triple triangle equation? And let's write that triple triangle equation as 3x squared plus 0 times x plus 1 is now equal to a x squared plus bx squared minus 2bx plus a cx minus 2c. So how is this helpful? Well, the only thing left to solve for is b. So why don't we look at the coefficients in front of the x here? That tells us that negative 2b plus c has to be equal to 0. So b is equal to c over 2. That means b's got to be equal to negative 1/4. All right, looks like we have everyone. So now this is equal to 13/4 over x minus 2. B was negative 1/4. So minus 1/4 over x. And c was negative 1/2. So negative 1/2 over x squared. So this form here is usually good for a calculus class. If you're in an algebra class, you're probably tempted to write this. You may actually write this as well, 13 over 4 times x minus 2 minus 1 over 4 times x, and then minus 1 over 2 times x squared. However, I'm going to circle the preference that's needed in a calculus course. So I'm going to circle that one as your final answer.